All right, what are radicals? The square root thing. Very good. Radical expressions. We have a baby unit here on adding and subtracting and multiplying and dividing radicals. So today we're adding and subtracting. Thank you. Oh, there! Look at that magic. All right. So we learned how to simplify radicals. And you just had a test on it. Aaron, turn around. You just had a test on it, and you all did quite well. And so we're going to do a little bit more work with those. So here you go. Take a second and write down your list of perfect squares, ladies and gentlemen. Find the perfect squares. And it's not quite getting the whole thing here. There you go. There we go. There we go. Okay, there it is. Find the perfect squares. My daughter is taking algebra as well. She just took a test on the perfect squares from 1 to 30. I thought that was a little excessive. I mean, what the hell are calculators for anyway? This is 1 to 19, which is fine. I could have included 20, but 20 squared is close. 400. Yeah, okay. All right, you guys have 1 minute. You can use the calculator, it's fine. If you need to use a calculator, I'm hoping you know your perfect squares from 1 to 12. They should be lickety-split. Oh, I love seeing those calculators out on desks. You can expect to see these lists of perfect squares come up in notes for the next couple of days. The idea is that each time, hopefully, you use the calculator less and less. All right, I'm going to give you 1 more minute. All right. So these are the list of perfect squares, and I just want to talk about, again, the reason why they're called perfect squares while you're finishing this up. When we multiply, we're actually creating an area. And so if I were to say, hey, what is the length of 17 times the width of 17, you would tell me that it is 289. Well, if it has a length of 17 and a width of 17, what shape is it? It is a square. And that's why 289 is called a perfect square. So this number is a perfect square in shape. Okay, and that's why they're called perfect squares. So now, if you know your perfect squares, then the fastest and best way to simplify square roots, like the square root of 196, is to know that, hey, if we have 196 is 14 squared, then the square root of 196 must be 14. Square roots, because there's this little index of 2, square roots undo perfect squares and take them back to their base of 14 in this case. And so you could think, what's the square root of 121? 11, very good. Now, let's go back and review really fast, because 121, we know, is 11 times 11. And didn't I tell you that when we're simplifying square roots, we're looking for a group of 2? Yeah? One gets shot and one escapes. Remember that? So same thing. The nice thing is that if we get a number that happens to be a perfect square, like 196, if I know it's a perfect square, do I have to divide by 2 and divide by 2 and divide by 2 a whole bunch of times? I don't have to. So knowing our perfect squares helps us simplify radicals really well. So now we're going to advance ourselves and look for perfect squares whenever we can. Look for perfect squares. Now, today we are adding and subtracting. So example 1, we want to simplify the expression. So to simplify the expression, here is your rule. You must have like radicals. Like radicals, much like terms, they have to have a common radicand. Radicands are the things on the inside. So this, I like to say, hey, 5 radical 14s minus 8 radical 14s is?
3 radical 14s.
Almost? Negative 3 radical 14s. This is the exact same idea as 5x minus 8x's is negative 3x's. These are what are called like radicals because they have the exact same radical. Square root of 14 in both of them. Okay? This is simplified. That's all I can do. All right? Do we have like radicals here? No. But I can simplify first. On this square root of 8 here, I need to simplify that. 8 breaks apart into what times what? 4 times 2. Wow, 4 is such an awesome number. What kind of number is 4? Perfect square. Perfect square. So what is the square root? Oh, it is a 2 times 2. What is the square root of 4? Here's one thing we can do. This technically means this 4 is under a radical and this 2 is under a radical. And there's a 7 being multiplied in front. We know now that because 4 is a perfect square, what's the square root of 4? Just 2. Hey, handy. Okay. Can I simplify the square root of 2? No, because 2 is prime. All right, so that stays. And 7 times 2 is 14. So really, 7 radical 8 is actually 14 radical 2. Do you suppose you can check that? Sure, you can always use a calculator. Let's see if they're the same. 7 radical 8. You have a radical button on your calculator. It's probably a color blue. And you can get a decimal. Crazy decimal. And we can try 14 radical 2. What are we expecting to see? Same decimal. Yay! We did it right. Okay? Good to check that thing. All right, what about 18? Can we simplify radical 18? Yes, we can. All right, let's think about that. First of all, this is like a -1. So we have a -1 out in front. And 18 is what times what? 6 times 3. Or 9 times 2. Ladies and gentlemen, why did I choose 9 times 2?
Because 9 is
Because 9 is a magic number. It's a perfect square. So we're looking for beautiful perfect squares. So this is really the square root of 9 times the square root of 2. Since they're both under the radical. What is the square root of 9? Just a 3. We have a -1 times 3. And again, I cannot simplify radical 2. And -1 times 3? Good. All right. Hey, look. That's nice. All right, let's look at -1 radical 50. Again, radical 50. Ooh, what times what is 50? 25 times 2. Very good. 5 times 10 is good. But 25 times 2 is better. Because why? Perfect square. So we have -1 times the square root of 25 times the square root of 2. And what is the square root of 25? 5. Very good. Now, I want to also say that I'm writing a lot of steps here. -1 times 5 is -5 times radical 2. One more step, ladies and gentlemen. 14 radical 2's minus 3 radical 2's minus 5 radical 2's is 6 radical 2's. Very good. These are like radicals. 14 of them minus 3 of them minus 5 of them gives you 6 radical 2's. Okay, I'm showing a lot of steps. But if you can go from here to here, that's good. And if you can go from here to here, that's even better. Okay? So I do like to see this step written out, and then you can think, hey, what's the square root of 4? 2 times 7 is 14. Okay? So I'm showing all the steps, but this is notes. You need to decide how much you need. Does that make sense to you? Yeah? Okay. Alrighty. Uno más. Last one. Letter C, we got 5 radical 8x plus 9 radical 200x minus minus radical 75x. First of all, there's a radical. There's always a number in front of it. What number is in front of this radical? -1 in this case. But yes, if there wasn't something there, it'd be a 1. A positive 1, if we will. Yeah. Always a 1. At least a 1. -1 in this case. All right. Let's simplify. I'm going to look first here. We have 5 times. Ooh, what can we do with the 8? 4 times 2 times x. Very good. And 4 is a good choice because what's the square root of 4? 2. So can I simplify and just do 5 times 2? And can I do anything with the 2 and the x? No. The square root of 4 comes out as a 2. And that becomes 10 radical 2x's. Okay. Here I have a positive 9 times the square root of. Tell me about 200x. What can we do there? 100 times 2 times x. Very good. And 100 is magical because it's the square root. Yeah. What does it come out as? 10. Yeah, it's 2 10s inside, but comes out as a single 10. So we have the 9 times 10 radical 2x, which gives me 90 radical 2x's. And then over here, last one, we have a negative 1. Tell me about 75x. 25 times 3 times x is very good. 25 is magical. What does it come out as? 5. Very good. There's that negative 1 we're multiplying. And inside we have a 3x. What's negative 1 times 5? Good. Radical 3x. Ladies and gentlemen, which ones are like radicals? The 10 radical 2x plus 90 radical 2x is 100 radical 2x's minus 5 radical 3x's. That one was not a like term, so it stays separate. Okay? Do you have questions for me? It's pretty easy, yeah? All right, looking for perfect squares is way better than breaking this down into 2 times 2 times 2 times 2 times. Oh, lots of 2's. Okay. Okay, great. This is all. You have a worksheet. You can do your work on the worksheet and then put it in the orange bin when you're done.